We can also use washers to find the volume of revolved solids formed by sections that are spun around arbitrary horizontal and vertical axes. And let's focus on this second case. So if we designate the distance from this vertical axis to the y-axis as d, and the distance from the y-axis to the outer washer as x1, well, the radius of the outer circle of the washer is then d plus x1. Then squaring that and multiplying by pi gives the area of that outer circle of the washer. And then we subtract the area of the inner circle. So the radius of that inner circle is going to be d plus this distance over here, which we'll designate as x2. And then squaring that and multiplying by pi gives that area of the inner circle. And then given the washer a thickness in the vertical direction, so that would be dy, gives the volume of that washer, and then we can integrate from y equals a to y equals b, and that gives the volume of the solid. And I encourage you to try this for this case over here, where we're revolving this triangular section about an arbitrary horizontal axis. Let's find the volume of the solid formed by revolving this region around a horizontal axis passing through y equals -1. So because the region is not touching that axis, we can use washers. And the area of the outer washer is pi by the radius squared, which is 1 plus y squared. And then minus the area of this inner washer, which is pi multiplied by the radius squared. And then we assign a washer a thickness in the horizontal direction, which gives the volume of the washer. And then integrating this from x equals 0 to x equals 1 gives us the volume of the revolved solid. So you can substitute for y equals x from this equation and evaluate the integral. Let's find the volume of the solid formed by revolving this region around a vertical axis passing through x equals -1. So because the region is not touching that axis, it's convenient to use the washer method. So the area of the outer washer is pi by the radius squared, so that would be 1 plus 1. And then minus the area of the inner washer, which is pi by 1 plus x squared. And then assigning the washer a thickness in the vertical direction gives the volume of the washer. And then we can integrate from y equals 0 to y equals 1. And that gives the volume of the solid. And now you can substitute for x from this equation and evaluate the integral and post your answer in the comments. Find the volume of the resulting solid when the region bounded by the parabola and the cubic from x equals 0 to x equals 1, so this region here, is revolved around the horizontal line passing through y equals -3. So we can conveniently use washers here because these curves are not touching the axis of revolution. So the area of the outer washer is pi by the radius squared, so the radius is 3 plus y, which is x squared all squared. And then minus the area of the inner washer would be pi by the radius, so that would be 3 plus y, which is x cubed. And then we give the washer a thickness in the horizontal direction, so that gives the volume of the washer. And then we integrate from x equals 0 to x equals 1, and that gives us the volume of the solid.